Today we are going to learn about position and electronic configuration of D-block elements. D-block elements are the collective name for the groups 3 to 12, in which the d orbitals are progressively filled in each of the 4 long periods. D-block elements are also known as transition metals. This is because they have the properties between highly reactive metallic elements of S block, which are typically ionic compounds, and the metals of P block, which are largely covalent. There are three main series of transition elements. They are 3D series. This includes the elements from scandium to zinc. 4D series. This includes the elements from yttrium to cadmium. 5D series. This includes the elements from lanthanum to mercury. The fourth series, that is the 6D series, which begins with actinium, is still incomplete. The 3D series, also called as first transition series. In 3D series, filling up of 3D orbitals takes place. It starts from scandium and goes up to zinc. The 4D series, also called as second transition series. It involves filling up of 4D orbitals. It starts from yttrium and goes up to cadmium. The 5D series will be called as third transition series. It involves filling up of 5D orbitals. The first element of the series is lanthanum. Then it will be followed by 14 elements called lanthanoids, which will be placed at the bottom of the periodic table. They involve filling up of 4f orbitals. Then you will have the elements from hafnium to mercury belonging to 5D series. The 6D series, also called fourth transition series. It involves filling up of 6D orbitals. The first element of the series is actinium. It is followed by 14 elements called actinoids, which also be placed at the bottom of the periodic table, as they involve filling up of 5D orbitals. The 6D series is an incomplete series. Now let's discuss few questions that can be asked from the introduction part of D-block elements. The first question is, what are transition elements? We know D-block elements are also called as transition elements. These D-block elements involves filling up of d orbitals. So these transition elements can be defined as elements in which d orbitals are incomplete in their ground state or in any one of their oxidation state. The next question is, why zinc, cadmium and mercury are not regarded as transition elements? If you take zinc, cadmium and mercury, they are placed in group 12 of D-block elements, and they have completely filled D10 configuration in their ground state as well as in their common oxidation state. So they are not having incomplete d orbitals in its ground state or in any one of its oxidation state. So they are not considered as transition elements. The third reasoning out question is, why scandium is a transition element whereas zinc is not? This is because scandium has incomplete 3D orbitals in its ground state, whereas zinc has fulfilled 3D orbital in its ground state as well as in its most common oxidation state. The fourth reasoning out question that can be asked is why copper is considered as transition element though it has fulfilled 3d10 configuration in its ground state. We define transition element as an element which has incomplete 3d orbital in its ground state or in any one of its oxidation state. If you take copper, it has fulfilled 3d orbital in its ground state, whereas in its plus 2 oxidation state, it has incomplete 3d orbital. So it can be considered as transition element. The general electronic configuration of D block elements are n-1, D 1 to 10, Ns 1 to 2. In 3D series, chromium and copper have exceptional electronic configuration. If you take chromium, it has valence electronic configuration 3d5 4s1. But the expected one is 3d4 4s2. Similarly, if you take copper, it has electronic configuration 3d10 4s1. But the expected one is 3d9 4s2. Why chromium and copper have exceptional electronic configuration is because of very little energy difference between n-1d and ns orbitals. The second important reason is we all know half-filled and completely filled electronic configuration are relatively more stable.